Good day, Engineer Krijaldi Degade. We are Group 6 and we are here to present our midterm presentation for plug flow reactor. Let's first see the objective of our experiment, as well as the short introduction to get a better idea. First objective, to determine the rate law for the reaction between ethyl acetate and sodium hydroxide using plug flow reactor at constant temperature. Second, to compare the variations of conversion with respect to resident time. The plug flow reactor model, sometimes called continuous tubular reactor, is normally the name given to a model used in chemical engineering to describe chemical reactions in continuous, flowing systems of cylindrical geometry. The PFR model is used to predict the behavior of chemical reactors of tubular design, so that key reactor variables, such as the dimensions of the reactor, can be estimated. A plug flow reactor consists of a long, straight pipe in which the reactive fluid transits at steady state having no accumulation. The main assumptions of this model are that the fluid is completely mixed in any cross-section at any point, but it experiences no axial mixing. Contiguous cross-sections cannot exchange mass with each other. In this analysis using the PFR, we are to determine the rate constant of the saponification of ethyl acetate with sodium hydroxide. Reaction is shown. The materials that we used for this experiment are conductivity meter, ethyl acetate, and sodium hydroxide. This is the procedure that we do in the experiment. First, we set the required temperature and stock concentration for NaOH and ethyl acetate. Next, we wet the flow rate of ethyl acetate in order to get the flow rate of NaOH. We fill the reactor and wait for the reactor to achieve steady state and add the readings to observation. After that we note the readings in 20 seconds with 3 seconds intervals, and beyond 20 seconds it will be a 5 seconds interval. Then we repeat the procedure with different M and temperature. Let's now move on to the experimental setup of our virtual laboratory. This is the virtual setup for the experiment. For our materials, we need a conductivity meter. For the reagents, we have the ethyl acetate and the sodium hydroxide. In this plug flow reactor experiment, sodium hydroxide and ethyl acetate undergoes a saponification reaction. Reaction rate constant and activation energy will be determined. This experiment was conducted through a virtual laboratory. Both of the reactants will be placed in the reactor with a 0.040 m stock concentration of ethyl acetate and sodium hydroxide, and reaction temperature of 30 degrees Celsius to 50 degrees Celsius with an increment of 2 will be used. The flow rate of the reactants should be equal to the total flow rate. The data gathered from the several flow rates and conductivity value, time, conversion of the reactions and the reaction rate constant is determined through a series of calculations by using formula for plug flow reactor experiment. The data shows that as temperature increases, the rate constant, K, will also increase. Thus, temperature is directly proportional to the value of rate constant. Here's some of our calculations in order to get the desired data that we use to utilize the aim of the laboratory experiment. For our conclusion from the virtual laboratory experiment, the flow rate of the ethyl acetate is set to be constant where the flow rate of sodium hydroxide depends. When we compare the PFR to the previous reactor, we concluded that it has higher efficiency of the same volume. This is because MFR maintains uniform concentration at any point in the reactor, while PFR has no axial mixing and has only radial mixing. As the concentration increases, the rate will also increase based on the calculated data of 5.344 to 16.424 liters per gram mole Kelvin. Also, based from the results, the activation energy E is 30,252.15, 37,347.32, 24,892.12, 57,403.18, 41,545.06 and 73,626.29 joules per mole respectively. While rate constant K is 1.10 E plus 0.6, 1.22 E plus 0.7, 1 E plus 0.5, 2.95 E plus 6.12 E plus 0.7 and 1.45 E plus 9 all are in liter per gram mole minute respectively. Hence, rate of reaction is directly proportional to reactant concentration. For the hazardous decomposition products of sodium hydroxide are sodium oxides and may be reacted with other type of chemicals that cause more hazardous products such as strong acids that rapidly release heat, like hydrochloric, sulfuric, and nitric, and also metals that form flammable and explosive hydrogen gas, like aluminum, lead, zinc, and tin. For the hazardous decomposition products of ethyl acetate are carbon monoxide, carbon dioxide, ethyl alcohol, and acetic acid. Since ethyl acetate is flammable, sources of ignition near the chemical such as smoking and open flames are strictly prohibited. For the hazardous decomposition products of sodium hydroxide are sodium oxides and may be reacted with other type of chemicals that cause more hazardous products such as strong acids that rapidly release heat, like hydrochloric, sulfuric, and nitric, and also metals that form flammable and explosive hydrogen gas, like aluminum, lead, zinc, and tin. For the hazardous decomposition products of ethyl acetate are carbon monoxide, carbon dioxide, ethyl alcohol, and acetic acid. Since ethyl acetate is flammable, sources of ignition near the chemical such as smoking and open flames are strictly prohibited. For the waste disposal, in disposing chemicals, always check the list of hazardous waste or its MSDS to perform proper disposal and prevent more serious effects on our environment and persons who will be in accidental contact with the disposed chemicals. Since sodium hydroxide is a strong base solution that is categorized as hazardous waste, it needs to be neutralized with an acid solution before disposal. Same with ethyl acetate, that is also categorized as hazardous waste for the reason that it is a flammable liquid vapor solution. It should be disposed away from all possible sources of ignition and incompatible materials such as oxidizing agents, acids, and alkalis. This is some of our raw data that we have gathered. Thank you for listening.